What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be working on Haworth to Fischer to chair conformations, okay? So, we're working in Doctrine to Series class, Chem 118C. We're given a D glucose. How do we know it's a D glucose? When it's D, it's going to be we're going to be looking at the stereocenter that's furthest away from the carbonyl group, which is right here. And we're going to look to see if our OH group is on the right. That would give us D. And if it was on the left, that would give us L. So L for left. Okay, so this is our Fischer projection. Let's go ahead and see what our Haworth projection would look like after we do a reaction such as this. So we're going to go ahead and number this as 1, 2, 3, 4, 5, and 6. Let's take this OH and let's react at this carbon here, okay? And let's push that guy up. So let's see what we get. So I know my general structure of my carbohydrate looks something like this, okay? So let's go ahead and number before we start doing substituents. 2, 3, 4, 5, 6 carbons. Okay. So coming off of carbon number 1, this is a special carbon. Let's go ahead and put a star here. Okay, this is going to be our anomeric carbon. This is our anomeric carbon. So when this oxygen hits this carbon, it's going to push this group up here to become O negative. So we're going to get something like O negative. And we can end up protonating this group. It's going to go grab a hydrogen and it's going to reform an OH group. Okay, so I know an OH group is going to be coming off of this carbon. What I can do is for now, I'll go ahead and put a squiggle to represent that this could have been the beta or the alpha anomer, okay, anomeric carbon. Another special thing we could do is I can actually take this molecule and I could flip it on its side. So I'm going to go ahead and do that. So I'm flipping it this way, okay? So that means if I label here, this is carbon number 1, 2, 3, 4, 5. So let's do 2, 3, 4, and number 5. If I do that, if I just go ahead and topple it over on its side to the right here, this OH group that was on the right is now going to be facing downwards. And this OH group on the left is now going to be coming upwards. So here's my OH group, carbon number 3. Carbon number 4, let's topple it over. I have an OH group going down. And carbon number 5, this guy is also going down. Great. And then carbon number 1, we had our carbon group with an aldehyde, and here we had a CH2OH group. Okay, so that's how we can take our Haworth projection, and we can take our Fischer projection and know what it's going to look like on our Haworth. So here, our number 2 carbon is going down, so I know to draw my OH going down on my Haworth just like this. Number 3 is going up. Number 4 is going down. And number 5, this is special, right? Because number 5 here, this OH would have been going down, right? Here's that OH, it's going down. That is this carbon right here, okay? So this OH would have been going down. You can think of, in order for this reaction to happen, this OH needs to be as far away as possible from this group. So if this OH was going to be facing down, we can assume that this CH2OH was way out of the picture, meaning it was probably pointing upwards. It wanted to be as far away as possible as this OH group. So if this O is right here, coming off of carbon number 5, that means I can draw this going upwards. Going upwards just like that. That's how I knew to put the substituent coming off of carbon number 5 to face upwards. Now, let's go ahead and draw our chair conformation now. So I know my chair looks something like this. Let's go ahead and get that chair conformation in. Okay, so let's label it as, let's see how I want to label this. We could have a chair flipped. So what I can do before I draw the substituents, I'm going to flip the chair, which means I'm going to highlight a couple regions here to show you exactly how we flip the chair. You can think of this, the top of this bow tie here. In order to flip the chair, I'm going to bring this group down, and I'm going to bring this group, and I'm going to push that upwards. So now, when I flip the chair, we can keep track of everything and see where everything went, okay? So if this group was pulled downwards, that's going to be right here. And if this group was pushed upwards, that's going to be this group right there. So now let's go ahead and try to figure out where that O went. Where's that O? That O group is now going to be right here. So if I numbered my carbons as 1, 2, 3, 4, and 5, and here I have 1, 2, 3, 4, and 5, we can now look at the substituents. So let's say we were talking about beta-D glucose. So let's go ahead and say we're talking about beta-D glucose. All right. The beta anomer would be, if we were looking under anomeric carbon, beta for bird, that group would be pointing upwards. Okay, so this is going up. And if it was the alpha, it would be like a fish down in the sea, and that would be going down. So let's just say we're talking about the beta anomer. So let's go ahead and draw the beta anomer here. Instead of the squiggle, I'm going to show the beta anomer pointing upwards. So if we're looking at carbon number 1 here, this is going to be an OH. Carbon number 2, this OH is facing downwards, so we have an OH there. Coming off of 3, our OH is pointing up. And number 4, our OH is pointing down. Notice they're all axial right now. And off of number 5, we still have this CH2OH group pointing up. Now you can see we have a beta-D glucose, and right now in our chair conformation, they are all axial, which we know this is going to be highly unstable. But because this is in constant equilibrium with one another, we can flip our chair and see if we get a more stable conformer. So now, keeping track of all of our carbons, we're at carbon number 1. If we flip the chair, if an OH group is pointing up, it's going to stay pointing upwards. So here, this is the position where the OH is now going to be pointing upwards. And at carbon number 2, it's pointing down. So here we can put down. Number 3, it's pointing up. So we can put the OH group pointing up. Number 4 is down. And number 5 has the CH2OH pointing up. Now notice these are all equatorial. And these were axial. So we know that this is going to give us the most stable conformer of beta-D glucose. They're all equatorial. So this is how we interconvert between the Fischer and the Haworth and our chair conformations. We also now know how to flip our chair conformation. And we see we're dealing with beta, and here at the anomeric carbon, this is pointing upwards, so this is still going to give us that beta conformation. That bird is still up in the sky, okay? So I hope this helped. Go ahead and give this a try. Practice, try with fructose, and I'll see you guys next time. So I wanted to add a quick note here. Let's go ahead and look at carbon number 1 and carbon number 5 in a little bit more detail. Now, in this exact Haworth projection here, we're saying that the carbon number 1 is the anomeric carbon that has an OH group pointing up, and we said that this was going to be beta. It's also important to consider what's happening at C1. So if we consider C at C5, if we consider C1, and C5, if both of these groups are pointing in the same direction, that is, if they are cis to one another, let's say they're both pointing upwards, then this is going to tell us whether it's going to be a beta or a alpha sugar. So if they are cis, that's going to give us the beta. Now if we do C1 and C5 and they're trans to one another, let's say I had something that looked like this with an OH going down. Well, this would be beta, this would give us the alpha conformation. This would be alpha D-glucose, okay? Now, another thing I want to say is if we're looking at C5, carbon number 5, if that group is pointing upwards like it is here, this is going to tell us whether it's a D or an L sugar. If instead we had something that looked like the hydrogen was here and our CH2OH group was pointing down, this is a key indicator that this is an L sugar. Okay, so most of our D sugars are going to be pointing upwards like this. Just keep in mind that if these groups are pointing away from one another, then that's going to give us the alpha conformation. But up here, if they're pointing in the same direction, then that's going to give us the beta animal. Okay?